Like all living beings, humans strive to preserve their lives and avoid death. However, unlike other mammals, we possess a well-developed neocortex, an area of the brain that makes us acutely aware of our mortality. Although death holds a significant place in culture, humanity has always sought and continues to seek ways to overcome it. In mythological traditions, gods were considered immortal. In Greek mythology, for instance, the gods resided atop Mount Olympus, a realm separate from the world of mortals. Similarly, the Scandinavian gods were believed to dwell in Asgard and could only be slain in battles with other deities. It was these gods who bestowed the gift of immortality upon mortals. In Buddhism, the concept of immortality is not viewed as a physical state, but as a spiritual liberation from the cycle of rebirth, samsara. According to Buddhist teachings, all living beings are subject to endless rebirths governed by the laws of karma. The ultimate goal for Buddhists is to attain nirvana, a state of complete liberation from suffering and desire, thereby breaking the cycle of rebirths. In this way, Buddhists believe true immortality is achieved. In ancient China, the quest for immortality was pursued through alchemy. Qin Shi Huang, the first emperor of a unified China, was so fearful of death that he commanded his court alchemists to find the elixir of life. Ironically, the all-powerful emperor died prematurely at the age of 49. It is believed that the pill of immortality he consumed contained mercury, a toxic substance. Humanity's methods for seeking immortality are diverse, ranging from folklore and tales of living water to advanced medicine and technology. The alchemical substance known as the Philosopher's Stone was considered capable of granting eternal life, a concept popularized in 18th century novels. Immortality has been attributed to several historical figures, such as Nicholas Flamel and the court of Saint Germain. Sir Galahad, one of King Arthur's Knights of the Round Table, is said to have gained immortality through the Holy Grail. Countless stories exist about fountains of youth, springs of life, and mysterious elixirs. In early 20th century Russia, there were large-scale transformations in all spheres of life. It was a period of change, not only in art and science, but also in society. During the first decade of the 1900s, naturalist and thinker Vladimir Verdansky conducted expeditions to study radioactive minerals. His research contributed to the development of nuclear energy and led to the emergence of the new science of biogeochemistry. Within this field, Verdansky explored the interactions between humans and nature, focusing on concepts like the biosphere and the noosphere. The biosphere is Earth's outer shell, populated by living organisms, while the noosphere represents a stage in the biosphere's development associated with the emergence and establishment of human civilization within it. These discoveries became a powerful stimulus for the development of creative ideas. Art, literature, music, and theater became closer to science than ever before. Ultimately, people believed that science would help humanity attain immortality. The philosophy of cosmism, a branch of thought that viewed humans as part of the cosmos and sought to understand our place in the universe, influenced those who believed that death could be conquered. Within the ideology of anarchism, the movement known as biocosmism emerged, conceptualizing freedom not only from authority, but also from death and any boundaries. Biocosmists were the first to unite all approaches to achieving immortality. Their theoretical works mentioned methods such as rejuvenation, anabiosis, and practices of physical resurrection. In the mid-20th century, the practice of cryonics, the preservation of bodies or body parts through deep cooling, was developed. Originating from scientific research focused on freezing and preserving biological tissues and organs, cryonics has continued to evolve, although it remains not widely recognized within the scientific community. Modern cryonics is based on the belief that, in the future, technological advancements will allow for the revival of those who have been frozen after death. Toward the end of the 20th century, cryonics gained significant attention. The idea of achieving physical immortality became prominent in literature, art, film, and science. Around this time, marine biologists discovered the jellyfish Turritopsis dohrnii, noted for its unique regenerative abilities that render it biologically immortal. On July 5, 1996, a mammal was successfully cloned in Scotland. This is the story of the famous sheep named Dolly. Born at the Roslin Institute, Dolly was created by transferring the nucleus from a mammary gland cell of a donor sheep into an enucleated egg cell of another sheep. The egg cell with the transferred nucleus was then stimulated to divide and implanted into the uterus of the third ewe, which carried Dolly to term. This method, developed by Scottish embryologist Ian Wilmot, is known as somatic cell nuclear transfer and represented a crucial step in animal cloning, moving humanity closer to overcoming biological limitations. Throughout history, humanity has tirelessly fought against death using science, particularly medicine. This struggle likely began with the dawn of human civilization. While many victories have been achieved, some stand out. In 1534, Flemish anatomist Andreas Vesalius published On the Fabric of the Human Body, providing a comprehensive description of human anatomy. In 1796, English physician Edward Jenner developed the world's first vaccine, which protected against smallpox. The 19th century saw the first experiments with anesthetics such as nitrous oxide and ether gas. In 1895, Wilhelm Röntgen discovered X-rays, revolutionizing medical diagnostics. Immunologist Karl Landsteiner identified blood groups, enabling safe blood transfusions. In 1921, Canadian scientist Frederick Banting isolated insulin, a hormone crucial for regulating blood sugar levels. The discovery of penicillin by British bacteriologist Alexander Fleming in 1928 ushered in the antibiotic era. In the 21st century, technologies like artificial organ growth in laboratories, effective HIV treatments, functional magnetic resonance imaging, targeted cancer therapies, the cyberknife system, bionic prostheses, and advancements in nanomedicine have emerged. Historical data indicate the average human life expectancy has changed dramatically over time. A general analysis reveals the following trends. During the Stone Age, life expectancy was approximately 20 to 30 years. In ancient civilizations like Egypt and Mesopotamia, it was increased to around 30 to 40 years. In medieval Europe, average life expectancy fluctuated between 20 and 35 years due to frequent epidemics, wars, and limited medical knowledge. During the Renaissance and early modern period, life expectancy began to rise gradually owing to improved living conditions and scientific progress. In the 18th and 19th centuries, it reached about 40 to 50 years. In modern times, thanks to advancements in medicine, sanitation, and nutrition, life expectancy in developed countries has significantly increased to approximately 75 to 85 years. Contrary to the popular belief that people aged 35 to 40 were considered old before the 19th century, such judgments are actually a myth resulting from statistical errors. Life expectancy data do not accurately reflect the life expectancy of people in different eras, primarily because of the impact of high infant mortality, which significantly lowered the statistical figures. A rapid decline of infant mortality began in the second half of the 20th century. For example, the global infant mortality rate was about 16% in the early 1950s, and by 2015 it had fallen to 3%. As a result, global life expectancy increased from 48 years in 1950 to 73 years in 2015. Immortality can be seen as a vector, the direction of humanity's development. Observing our civilization, we can assert that the pursuit of immortality has been the goal of mankind since the beginning of history. Initially, immortality was studied through myths, legends, and cultural narratives. By creating concepts of the afterlife, people sought to protect themselves from encountering the most frightening aspects of existence: the unknown, the abyss, the darkness. In essence, medicine arose not as a result of evolution, but as a result of behavioral adaptation. It is a result of natural selection that continues to this day. Not surprisingly, this competition with death has spawned an entire industry. To illustrate that the quest for immortality has been going on for a long time, let's take a look at some of its key players. Amazon founder Jeff Bezos has reportedly invested $3 billion in the life extension project Altos Labs, a company developing cellular reprogramming technology aimed at turning specialized cells in the adult body back into stem cells. Stem cells in turn can differentiate into different types of cells, potentially allowing the body to regenerate damaged organs and tissues, thereby reversing the aging process. Yuri Milner, a Russian-born Israeli entrepreneur, has also invested in Altos Labs. Meanwhile, Google co-founders Sergey Brin and Larry Page have invested more than $2 billion in the creation of Calico, a biotech company that researches mechanisms of life extension. Calico scientists conduct fundamental research into cellular aging processes. The company is often criticized for secrecy and has yet to bring drugs or technologies to market, although such developments are expected before 2027. Sam Altman, CEO of OpenAI, has also invested in the quest for immortality. He has invested $180 million in startup Retro Biosciences, which aims to extend human life through plasma therapy and the study of autophagy, a mechanism of intracellular regeneration and purification. Some of their developments are already in clinical trials. Peter Thiel, co-founder of PayPal, has invested about $100 million in anti-aging research. The exact distribution of these funds has not been disclosed, but he has backed several startups in this field. One such company is Ambrosia, which was developing a rejuvenation technology using blood plasma transfusions from young donors to the elderly. Thiel was rumored to have undergone such procedures himself, allegedly spending about $40,000 every 3 months. Thiel has also invested about $7 million in the Methuselah Foundation, named after the biblical figure who lived 969 years. The foundation established the Methuselah Mouse Award, which recognizes researchers who have made breakthroughs in extending the lifespan of laboratory rodents. The first prize went to endocrinologist Andrzej Bartke, whose mouse did not live 6 days to its 5th birthday, the equivalent of 180 years in human years, given that mice typically live about 3 years. Brian Johnson, creator of the electronic payment processing company Braintree, has also invested more than $100 million in the pursuit of immortality. He founded OS Fund, a venture capital fund that finances biotech research. Johnson also founded Kernel, a company that makes helmets to analyze brain activity. The technology is expected to help people suffering from Alzheimer's disease, cognitive decline, strokes, and brain injuries. Brian Johnson himself spends about $2 million a year on rejuvenation procedures. At 47, he dreams of regaining the body of an 18-year-old. However, the trend of Silicon Valley billionaires investing in immortality has caused mixed reactions in society. For example, Bill Gates reacted wryly to the news that Google's founders had invested in Calico, saying, "At a time when millions of people are dying of malaria and tuberculosis, it seems pretty selfish for rich people to fund startups that will help them personally live longer." The 67-year-old patriarch of the computer revolution, along with his ex-wife, has reportedly spent $36 billion to fight disease and poverty. However, the motives of these billionaires may not just be to achieve personal immortality. I'm sure many of these tycoons are putting money into these projects for commercial reasons, says Andrew Steele, a scientist, author, and computational biologist. Steele mentions that experts estimate that real, effective anti-aging pills will appear in pharmacies in the foreseeable future. Such drugs would generate huge profits because every living person on the planet is a potential customer. This would be the most significant revolution in medicine since the discovery of antibiotics, and shrewd businessmen naturally want to be at the forefront of this industry. However, as we continue to hear news of billionaires passing away, it is clear that no secret cure for death has yet been invented. Despite this, there is no consensus among scientists and thinkers on the fundamental question: does mankind need immortality at all? At first, life extension technologies are likely to be expensive and unaffordable for most people. This could lead to social upheaval, creating another dimension of inequality between rich and poor. For example, Silicon Valley billionaires or political leaders may celebrate their 150th birthdays, while their employees may only live to be 80 years old. Such inequality hardly seems fair to anyone. Moreover, the possibility for some people to live indefinitely may lead to civilizational crisis. The passing of older generations makes room for younger ones, bringing not only new people but also new ideas. Paradoxically, if death did not exist, practices such as slavery or human sacrifice might persist. Phenomena that were once considered normal or even fundamental might have continued unchanged. Barbarism and prejudice became relics of the past precisely because those in power who maintained certain orders eventually died, allowing new generations to bring change. If death is defeated or significantly delayed for some, it is clear that progress can slow down, potentially leading to a global recession or crisis. In some regions, those in power may cease to be replaced. Business will no longer be hereditary, and change can only be achieved by force. Immortality, as you can see, is a very controversial topic. In this article, we will look at whether it is possible to become immortal from the point of view of physics. How did one Frenchman live out most of his life without a significant part of his brain? When can we achieve cybernetic immunity? How did this jellyfish manage to live for 66 million years? Where can the soul reside? How can consciousness be transferred onto a computer? And why we will always believe in immortality. Brace yourselves, the best part is yet to come. Don't forget to give us a like, leave a comment, and share this video with your loved ones. What do we mean by immortality? Although it is an abstract concept, even the universe is finite. What kind of immortality can we discuss for organic living matter? According to the hypothesis of the heat death of the universe, the cosmos will expand indefinitely, and stars will eventually burn out and die, leaving only cold and dark space. Alternatively, the Big Crunch theory suggests that the expansion of the universe may reverse, eventually contracting back into singularity. Before exploring possible ways to achieve immortality, it is necessary to define what it entails. Various cultural conceptions of immortality share the common idea of an indefinitely long life. Ethereal youth is usually implied, though there are exceptions. Immortality may or may not include protection from accidents, disease, and violence, that is, invulnerability. Thus, we can distinguish between complete physical immortality, the indestructibility of the body, and mere ethereal longevity. For comparison, consider the elves in Tolkien's works, who can die in battle but do not age, and the immortal Highlander Duncan MacLeod, who recovers from any mortal wound and returns to life unless his head is severed. Another question arises: is immortality of organic life forms possible in principle? American physicist and Nobel Prize winner Richard Feynman once wrote, "If man were to create a perpetual motion machine, he would face the limitations of physical laws. Energy cannot be created or destroyed. It only passes from one form to another. In contrast to this situation, there is no law in biology that states the obligatory finitude of each individual's life." Is it possible to achieve ethereal life, that is, endless longevity? We cannot yet claim to have achieved absolute invulnerability. What should persist into eternity? The whole person or some specific part? At this stage of our inquiry, we need to understand precisely what we aim to preserve eternally: the entire human being or a particular aspect. This is important because most religions assert that it is not the whole person with all anatomical features and unique pathologies, but a special part, the soul, that passes into eternity. From a scientific perspective, we recognize that some parts of the human organism are more crucial than others for preserving consciousness. For example, when a person loses an arm, leg, eye, kidney, or even receives a heart transplant, their personality remains intact. The brain is responsible for an individual's consciousness. We will not delve into the complexities of how other living organisms without a brain or with only rudimentary ones experience consciousness. We can confidently assume that all living organisms possess a form of proto-consciousness. Therefore, to ensure the eternal existence of a person with a distinct personality, we must preserve their consciousness for as long as possible. But what is necessary to maintain a person's personality? Must we safeguard the entire brain or specific parts of it? Can we transfer it to a new medium, organic or inorganic? Some scientists propose that the entire brain is responsible for human consciousness. They suggest that if brain damage is not critical, the function of the self can be transferred to undamaged regions. Therefore, the exact location of a person's consciousness does not exist in a specific area. It is dispersed across synaptic connections. In 2007, a Frenchman, whose name remains undisclosed, visited a hospital complaining of leg pain. After thorough examination, doctors diagnosed him with hydrocephalus, a condition where cerebrospinal fluid accumulates in the brain's ventricles. Astonishingly, scans revealed that he was missing up to 90% of his brain tissue. Despite this, the man was alive and functioning relatively normally. He had no severe mental disabilities, was a father of 2, and worked as a civil servant. Tests indicated that his IQ was 75 points. This value is the norm. Our consciousness, the aspect we wish to preserve, is like a reference point, the center of our world and decision-making, combined with personal history recorded in our nervous system, life experiences, knowledge, and perceptions of the external world, and how we interact with it. We believe our goal is achieved if a person's consciousness feels as it did before. It perceives itself as the center of the world, possesses free will, remembers its history, recognizes familiar people and places, and retains reflexes, skills, moral beliefs, and attitudes. Consciousness emerged at some stage in the evolution of living organisms, and in various ways helps them survive in a complex, changing world, including facilitating more effective communication with other organisms. In humans, the development of consciousness is genetically programmed. Like other mechanisms, such as romantic love, it manifests at a certain age and consists of specific neurons and their connections with our brain. While we are born with all our neurons, the information of the self requires the establishment of connections between these neurons during the experiences of our early years. Apparently, human consciousness fully unfolds around the 3rd year of life. By this time, a child's brain is almost 80% of the volume of an adult brain. The cerebral cortex and limbic system reach sufficient maturity to allow children to recognize and express various emotions, play, talk, and count. According to the theory of psychoanalyst Jacques Lacan, a child between the ages of 6 and 18 months begins to realize that the person looking back at them in the mirror is their own reflection. Lacan believed this realization indicates the formation of the structure of subjectivity, the self. The human body as a whole is an illusion created by our brain. You may have heard of the phenomenon of phantom limbs, where individuals feel sensations in limbs that have been amputated. People literally feel their arm even though it's gone. This phenomenon confirms that the brain creates a complete model of the body. These sensations occur due to the brain's reorganization of the body model, indicating that the model is plastic and can change. Philosopher Thomas Metzinger, in his book The Ego Tunnel, thoroughly analyzes this process. In his work, Metzinger considers the body as a key element in the formation of consciousness and perception of the environment. He argues that our perception of our own body is not a passive process, but is actively constructed by the brain based on sensory information. This means that our body is not just a physical object, but a product of cognitive processes that shape subjective reality. This gives hope that our ego can hypothetically accept a new body, a new shell, and integrate it into our consciousness. Surprising but logical. Without contemplating consciousness, we simply could not form a foundation for understanding immortality. It's not so important what happens to the shell. Consciousness is primary. It's time to explore the fundamental scenarios of achieving immortality. Are there immortal beings living on Earth? Yes, as mentioned earlier, the jellyfish Turritopsis dohrnii serves as a fascinating example. Discovered in the 20th century, its existence raised many questions, but today we understand what allows it to potentially live indefinitely. Turritopsis dohrnii is the only known multicellular animal capable of achieving biological immortality by reversing its life cycle and effectively resetting its aging process. Like many hydroids, aquatic invertebrates, Turritopsis dohrnii begins life as free-swimming larvae called planulae, which develop from fertilized eggs in the ocean. After drifting, these larvae settle on the seabed and repeatedly clone themselves, forming a colony of polyps. When the colony matures, new jellyfish bud off from the polyps, reaching maturity in a matter of weeks. For most hydroids, this marks the end of their life cycle. However, Turritopsis dohrnii has the unique ability to reverse its maturation process and revert to the polyp stage. Under unfavorable conditions, it can restart its life cycle at any time, forming new polyps and clones. To uncover the biological mechanisms behind this unique ability, a team of scientists from the University of Oviedo in Spain conducted a comprehensive genetic study of Turritopsis dohrnii and its related but not immortal species, Turritopsis rubra. They found that Turritopsis dohrnii possesses multiple copies of genes responsible for repairing DNA damage and maintaining telomere length, the shortening of which is associated with aging. Telomeres are often discussed as a key to longevity, acting as a biological clock within our DNA that influences lifespan. In multicellular organisms, including eukaryotes, DNA consists of coding and non-coding regions. Interestingly, non-coding regions make up a larger portion of the genome. This abundance of non-coding DNA plays a crucial role in regulating complex biological processes. Telomeres, located at the ends of chromosomes, have protective functions that play a pivotal role in cellular aging. They are composed of repetitive nucleotide sequences, invertebrates, which do not code for proteins. Their role is somewhat sacrificial, protecting essential genetic information during cell division. Each time a cell divides, enzymes responsible for DNA replication cannot fully replicate the ends of chromosomes, a limitation known as the end replication problem. This isn't a flaw, but a natural feature of DNA polymerase. Consequently, telomeres shorten with each cell division, acting as a countdown timer for cellular lifespan. When telomeres become critically short, cells enter a state called senescence, or may undergo apoptosis, programmed cell death. The typical limit of about 50 cell divisions is known as the Hayflick limit, named after Leonard Hayflick, who discovered this phenomenon. Hayflick and his colleague Paul Moorhead conducted a seminal experiment where they cultured human fibroblasts. They observed that cells have a finite capacity to divide. In their experiment, they mixed fibroblasts from male and female donors at different stages of cellular aging. The male cells had already undergone 40 divisions, while the female cells had only completed 10. When the mixed culture ceased dividing, only the female cells remained alive, indicating that the male cells had reached their division limit. Based on these observations, Hayflick concluded that there is an intrinsic limit to the number of times a normal human cell population can divide due to telomere shortening. This discovery has significant implications for our understanding of aging and the potential for cellular immortality. The idea of using telomerase for life extension focuses on slowing down or stopping the shortening of telomeres, thereby preventing cellular aging. This could be achieved by activating telomerase within cells or by introducing components into the body that stimulate its activity. However, it's important to note that research in this area is still at an early stage, and there is no definitive evidence yet that activating telomerase can actually prolong life. As we immerse ourselves in the microcosm, we might overlook what's happening on a larger scale. Could humans, like Turritopsis dohrnii, someday find a way to clone themselves? Cloning does not prolong the life of an individual, but could replicate a person's genetic makeup. Does it also extend the existence of a particular consciousness? Could two versions of the same consciousness exist simultaneously? Probably not, as conditions like dissociative identity disorder, formerly known as multiple personality disorder, are recognized in medical practice. This mental disorder involves a fragmentation of identity, where it seems that several different consciousnesses exist within one person. In such cases, a switch occurs where one part of the identity replaces another. These identities can have different genders, ages, nationalities, characters, mental abilities, and worldviews, reacting differently to the same situation. They may or may not share memories. However, the existence of multiple identities in a single brain does not suggest that consciousness can be transferred or copied to other media, whether biological or non-biological. Cloning humans is currently illegal or heavily regulated in many countries. Cloning is defined as the process of creating a human being that is genetically identical to another. Ethical prohibitions remain due to unresolved dilemmas about identity and personhood. For example, if we were to transplant one's consciousness into another body, would it constitute ending the original consciousness? Meanwhile, the rapidly advancing field of artificial organ creation is making significant strides. Scientists have learned to grow not only skin but also internal organs like the liver and heart, and they are working on creating artificial brain tissue. The production of organs is undoubtedly a significant advancement in medicine, but so far, these organs can only be used for transplants, not creating a new organism. For instance, it's possible to grow a new liver from your liver cells that will be virtually identical to the original. If your own liver fails, it can be replaced with an artificially grown one. However, combining artificial organs into a single, functioning system presents serious challenges. This requires considering many factors: the peculiarities of biochemical processes, cellular biocompatibility, and general homeostasis. It's not just about replacing one organ with another, it's about creating an entire system from scratch, from blood vessels and nerves to every fold of the skin and hair on the head. Even nature doesn't always succeed in creating a viable organism, as evidenced by the number of congenital abnormalities and statistics on death during childbirth. What can humanity achieve in this field? There is hope, however. We have valuable tools: neural networks. In the future, computers may be able to quickly model and synchronize the process inside the body and advise us on how to construct an artificial body that functions accurately. These algorithms could learn by studying living patients and then, using our data, build models of organisms and create assembly instructions for us. How will the artificially created organism be assembled? The answer is nanobots. Ray Kurzweil, one of the most influential futurists, inventor, and director of engineering at Google, claimed in a recent interview that by 2029, medical technology will enable humans to achieve immortality. While this is a speculative statement without concrete evidence, such bold predictions have made Kurzweil famous. A graduate of the Massachusetts Institute of Technology, he is a recognized expert in machine learning and speech recognition that is globally renowned for his work in futurology. Kurzweil actively promotes the concept of an inevitable technological singularity, a point at which progress becomes so rapid and complex that humans can no longer comprehend it. He envisions that artificial intelligence, biotechnology, and self-replicating machines will lead to complete material abundance, and medicine will grant us personal immortality. In one of his interviews, he explained, as early as the 2020s, nanobots will begin to be used, which will partially take over the functions of our immune system. Cybernetic immunity will enable future humans to avoid death. Microscopic devices will travel directly through the bloodstream and between cells in the human body, acting as artificial T cells that attack infections and cancerous tumors more effectively. We could program these devices to counter all possible pathogens and download updates from the internet to combat new dangers, such as emerging biological viruses. Medicine is already significantly increasing human life expectancy. However, according to Kurzweil, by 2029, this process will reach a qualitatively different level, increasing life expectancy by more than 1 year every year. It is worth noting that despite Kurzweil's authority in artificial intelligence, not everyone shares his futurist views. Although his reasoning is logical, some consider it illogical in the context of humanity's development. For example, Kurzweil predicted the emergence of a supercomputer with artificial intelligence more powerful than that of the human brain and a virtual reality capable of engaging all of our senses simultaneously by 2014. Kurzweil is a staunch advocate of singularitarianism, the belief that the world is on the verge of a technological singularity, an uncontrollable acceleration in technological development. This is his vision of the future and what he is working toward. Many people pin their hopes on the future, which is why they choose to have their bodies frozen. Cryonics technology was first proposed in 1960 by Robert Ettinger, an American engineer and writer. In his book, The Prospect of Immortality, published in 1964, he outlined the basic principles of cryonics and suggested that in the future, it might be possible to restore frozen bodies and cure diseases now considered incurable. It is believed that when temperature drops, all processes in the body slow down. Therefore, if you cool the body or brain to the temperature of liquid nitrogen, about negative 196 degrees Celsius, you can indefinitely halt all physiological processes. The main thing to remember about cryonics is that it is not yet scientifically proven. All procedures are purely experimental. So far, no one has been successfully frozen and then revived to full health. None of the current cryonics companies know if their patients will ever return to the ranks of the living. The responsibility for reanimation is passed on to future generations of scientists who may someday develop technology to revive and restore full function to organisms frozen today. As a spokesperson for the cryonics company Alcor once said, "There are no guarantees. We don't promise to bring you back on May 27, 2082 or anything like that. We don't officially know that it'll work. We don't know for sure that our organization will even survive. Maybe we'll get hit by an asteroid. There are no guarantees, but this possibility seems like the best alternative." In other words, according to Alcor, there is a much better chance of waking up from an icy slumber than after cremation. The main challenge in freezing complex organisms has been the destruction of cells due to cold temperatures. Human cells contain a significant amount of water. When cooled to freezing temperatures, well below negative 40 degrees Celsius for cellular contents, the cytoplasm turns into ice crystals. This ice occupies a larger volume than the water from which it had formed, and as it expands, damages the cell walls. If these cells are subsequently thawed, they can no longer function because their membranes have been irreversibly destroyed. However, this problem has a potential solution. Today, cryonics companies replace all the fluids in a patient's body before freezing with cryoprotectants, solutions that lower the freezing point and prevent ice crystal formation. These allow the body or brain to be cooled to the temperature of liquid nitrogen without damaging the tissues. Much of the scientific community views cryonics as just another method of body preservation, not as an opportunity to preserve life for future resurrection. For this method of life extension to be legal, the body must be frozen immediately after legally pronounced dead. Otherwise, it will be considered murder. Essentially, cryonics is somewhat like modern embalming. Transferring the responsibility for bringing cryopreserved bodies back to life to future generations is certainly an optimistic gesture. Now it's time to discuss the most controversial scenario for achieving eternal life: digital immortality. Until recently, technology evolved, but humans remained fundamentally the same. This has been the pattern throughout human history. Today, that era is coming to an end. The direct impact of technology on the brain is a matter of the coming decades. Many people are wary of such a development. However, there are enthusiasts of this new state of affairs. They call themselves transhumanists and consider cybernetic enhancement a blessing. Philosopher Nick Bostrom, a well-known advocate of transhumanism, believes that humanity is not the final stage of evolution, but its beginning. In contrast, political scientist and philosopher Francis Fukuyama considers transhumanism to be one of the most dangerous worldviews in the world. Information travels through wires in a computer much faster than through the nervous system of the human body. By learning to transfer human consciousness into electronic devices, we could create a symbiosis with enormous potential. As fantastic as that idea sounds, it is more feasible from a practical point of view than cryonics. To realize it, we need to learn how to model the entire human brain, digitally map it, and develop a way for the electronic brain to communicate with a computer environment. Startups around the world are already actively offering a wide range of services under the umbrella of digital immortality. Some create and place digital replicas of the deceased in virtual universes, while others allow you to communicate with simulated versions of your departed loved ones via chat. All models that exist now, while promising immortality, actually just recreate a copy of a person from existing data. This copy does not generate new, independent thoughts, although this alone is already a major technological breakthrough. But is it possible to truly transfer a person's consciousness, thoughts, and feelings into a digital space? With access to vast amounts of data, it is already possible to recreate aspects of a human being. Language models are capable of this. The Chinese room thought experiment comes to mind. However, what if we set a more ambitious goal: to transfer consciousness to an artificial medium? In engineering terms, the task can be formulated as follows. It is necessary to survive the destruction of the biological carrier, the death of the biological body, while ensuring that the surviving consciousness remains the original person, not merely a copy or imitation. If we copy all the neurons of a human being, we obtain just a replica, not the person themselves, because in the human body, neurons are constantly changing. This phenomenon is called neuroplasticity. These constant synaptic changes are hard to replicate precisely. To solve this problem, we could start gradually replacing parts of the brain with artificial components. Then the person wouldn't change, and their consciousness could hypothetically transition to artificial neurons. However, abruptly combining the human brain with digital devices, as in the neural interfaces being developed by Elon Musk's company Neuralink, could pose risks to the human mind. To understand the potential risks, let's conduct a thought experiment. Imagine it's the year 2060. You're in excellent physical health and don't suffer from any brain diseases, but you decide to undergo a preventative rejuvenation procedure. Your friends recommend a well-known company that can replace parts of your brain with microchips in just 1 hour, making it extremely artificial. Sitting in the waiting room, anticipating the surgeon's consultation, you feel a mix of excitement and nervousness. It's not every day that someone decides to replace their brain with microchips. When it's your turn, you ask the surgeon, "Will I still be myself?" The doctor confidently assures you that consciousness is generated by the brain, an abstract system of cause and effect relationships among its various parts. He explains that new brain scanning and imaging technologies can create a unique mind map, a schema that fully describes how your mental states interact to determine your emotions, behaviors, and perceptions. This way, even if your brain is replaced by microcircuits, your sense of self will remain unchanged. Reassured and encouraged by the doctor's explanation, you schedule the surgical procedure. During the surgery, the doctor asks you to stay awake and answer questions for safety reasons. He begins removing groups of neurons, replacing them with artificial silicone-based ones. The first area to undergo changes is the auditory cortex. As he works, the doctor periodically asks, "Do you notice any changes in the sound of my voice?" You respond that you don't. He completes that part and moves on to the visual cortex. You report that your visual perception hasn't changed, so he continues the operation. Before you know it, the surgery is complete. "Congratulations," the doctor exclaims. "You now have an artificial brain copied from the biological original." In our circles, people like you are called isomorphs. The purpose of philosophical thought experiments is to stimulate the imagination. In this case, the operation is deemed a success. But how would you feel after such a procedure? The same as before or different? Perhaps your first reaction would be to question whether the being that has emerged is really you or merely a copy. Let's assume that you remain the same person after the surgery. In that case, it's important to understand whether the quality of your consciousness would perceptibly change. In his book, The Conscious Mind, philosopher David Chalmers examines similar situations and argues that your experiences should not change. In his view, alternative hypotheses seem too far-fetched. According to one hypothesis, your consciousness would gradually fade as the microchip neurons replace the biological ones. This is akin to the way sound from a music player gradually diminishes as you slowly turn down the volume. At some point, just as the song ends, your consciousness simply fades away. Another hypothesis suggests that your consciousness remains unchanged up to a certain point and then abruptly shuts off. In both cases, the end result is the same. The lights go out. However, both of these scenarios seem unlikely. If the artificial neurons are indeed exact functional copies, as our thought experiment suggests, it's hard to see why they would cause gradual fading or sudden changes in the quality of your consciousness. After all, these duplicated artificial neurons, by definition, possess all the properties that play vital roles in your mental life. It's important to ask, is such a situation possible in principle? Does the creation of an isomorph contradict the laws of nature? And if it doesn't, will humanity ever achieve the technical level required for its creation? And will humanity ever choose to pursue it? At present, we cannot say with certainty whether alternative materials can reproduce the perceived quality of mental life. Perhaps we will discover this in the near future when doctors begin using artificial intelligence-based medical implants in the parts of the brain responsible for conscious experience. We could start with technology that interfaces with the peripheral nervous system. which is more readily available. Additionally, there is already a demand for neurointerfaces in the real economy. Whoever succeeds in creating a fully functional neural interface for gaming will, to put it mildly, achieve remarkable success. Immersive virtual worlds are already in demand, and such technology would make them incredibly engaging and seamless. Creating virtual environments to engage people's minds while conserving space and resources is also advantageous. As unnatural as it may sound, humans are increasingly merging with technology and algorithms at every turn. Perhaps conscious experiences depend on the quantum mechanical properties of the brain. If so, science may never be able to obtain all the information needed about the brain to create an exact quantum copy of a personality. Quantum constraints on particle measurement will prevent us from accurately determining the brain properties necessary to create a complete isomorph. The question of the quantum properties of the brain is one of the most complex and understudied areas in modern science. Currently, there is no definitive answer, as research in this field is still in its infancy. Hypothesized quantum properties include superposition, the ability of a particle to be in more than one state simultaneously, and quantum entanglement, non-local connections between particles. These properties may be important for understanding brain function, but their roles and mechanisms remain unclear. We have examined 5 scenarios for achieving immortality, extending life expectancy indefinitely. In scientific terms, infinity refers to the remaining time in our universe before it ceases to exist. Suppose immortality has been achieved in some way. What happens to us then? The point is that we consume more and more information every year. A technological singularity may be on the horizon. There is already an abundance of information, with more to come. Today, humanity may have reached the peak of its current cognitive development. To become a true scientist and to open new horizons in modern science, one must study practically all one's life, and even then can become a specialist in only a small field of knowledge. Unlike in antiquity, when scholars could be experts in many fields at once due to the limited amount of available information, today's vast knowledge base makes this nearly impossible. Attempting to memorize enormous amounts of information can lead to cognitive overload. There is a risk of going insane. Already we are suffering from information fatigue syndrome, the psychological challenge of the 21st century, which will become more widespread if we do not learn how to effectively manage information flows and to derive benefit from each piece of information. Digital minimalism is like a surfboard on which to ride the wave of information clutter in our era. Neuroscientist David Linden once described how he was preparing to face death due to heart cancer and the insights about brain function that came to him during that time. After the oncologist explained his condition, Linden felt anger at the world. Heart cancer? Who gets heart cancer anyway? Is this a joke? And this disease is going to take me away from my family, friends, and coworkers? The first realization for the neuroscientist was that a person could easily be in 2 opposite emotional states simultaneously. He was both angry about his terminal cancer diagnosis and grateful for all that life had given him. This observation contradicts the traditional view in neurobiology, which suggests that at any given moment, humans are in one of 2 physiological states, the fight or flight response or the rest and digest state, depending on which part of the autonomic nervous system is activated. However, our brains are organized in a much more complex manner. He then arrived at a second insight. There is no such thing as objective experience. Our brains are incapable of perceiving anything directly. Our perceptions are always influenced by expectations, comparisons, and specific circumstances. Half an hour flies by when conversing with a close friend, but the same period can feel like an eternity when we are stuck in an elevator with a dead phone. A bonus we receive seems like a fair reward, until we learn that a coworker received twice as much. Being touched by a loved one during intimacy feels good, but the same touch during an argument is perceived as a violation of personal boundaries. David's most profound realization was the impossibility of imagining his own death. Although I can prepare for death in a practical sense, getting my finances in order, making a will, writing letters of recommendation for trainees, I can't imagine my death in a world where I won't exist. I know I am not alone in this. After all, it is one of the properties of the human mind. Today, we understand that the brain doesn't merely react to external stimuli, but actively predicts the near future. Will a person on an electric scooter pass by? How soon will I be hungry? Who is that person walking towards me with a bat? This predictive process is subconscious and cannot be turned off by willpower. Because our brain is programmed to anticipate the near future, it assumes by default that this future always includes us. This is why we are unable to visualize our own death. This peculiarity of our consciousness has given rise to religion. Notice that almost all religions include the concept of life after death or reincarnation. Why? For the same reason that we are incapable of conceptualizing our own non-existence. Our brains are programmed to always plot some route on the map of time. Consequently, we all unwittingly believe in the infinity of our consciousness. Many religions are based on the idea that if individuals can follow certain rules during their lifetime, they will be rewarded after death with a better life, either a more favorable rebirth or a reunion with the divine. What would have happened to the world's religions if our brains had not been programmed to believe in the immortality of the soul? For the Epicureans, including Lucretius, the solution to this psychological dilemma about death was straightforward. Their perception is as follows. First, we must recognize our fear of death. Then, we must acknowledge that it is irrational to fear death. After all, the Epicureans argued, bad things can only happen to those who are capable of feeling, and the dead feel nothing, just as we did not before we were conceived. Being dead, then, is no different from never having been born. No one feels horror at the time before their birth, so why worry about death? It is exactly the same emotionless state that prevailed for billions of years before we were born. The Epicureans insisted that once we realize this, our anxiety about death disappears. We will stop longing for immortality, and this, Epicurus thought, would make our mortal life more pleasant. However, to counterbalance this, one cannot help but recall the image of an empty cradle from Vladimir Nabokov's autobiographical book, Speak, Memory. The cradle rocks above the abyss, and common sense tells us that our existence is but a brief crack of light between two eternities of darkness. I once knew a sensitive young man who suffered from chronophobia, not only concerning the boundless future, but also the infinite past. Watching a home movie made a month before his birth, he felt an acute sense of longing and panic. He saw a completely familiar world, the same environment, the same people, but realized that he was not in this world at all, that no one noticed his absence or mourned for him. Particularly haunting was the sight of the baby carriage just purchased, standing on the porch with the smug slouch of a coffin. It was empty, as if, as my young friend aptly put it, the very bones of time had vanished when time was converted into the imaginary value of the past. Humans, like all living beings, are biologically predisposed to resist the end of life. Any life form that readily accepts death would exit the evolutionary process rapidly. Our fear is generated by the limbic system, which helps us survive in a dangerous world. Later, the more complex neocortex was added to the limbic system, enabling us to comprehend our constant vulnerability and ultimate mortality. So far, Epicurean explanations are not enough for us to find peace and acceptance. The fact that we will one day cease to exist seems to render everything we do meaningless unless the hope of immortality, literal or symbolic, shines at the end of the tunnel. Literal immortality involves the belief that one will continue to exist after death, usually imagined beyond the physical world. Religions promise heaven or reincarnation in one form or another. Symbolic immortality is the continuation of life through the artifacts, ideas, books, and works of art we create. We can live on after death because we have become part of something greater than ourselves. This is why we strive to be part of meaningful groups that make a lasting impact on the world. This influence can manifest our creative achievements, the names of buildings, the legacies we pass on to our children, and the memories our loved ones will cherish. If one feels part of a heroic cause or nation long enough, one can taste the immortality of that cause or nation. People are overwhelmed by the sense of transcendence evoked by belonging to a powerful tribe, a great city, or a thriving, dominant empire. Passionate devotion to one's people and unwavering loyalty to charismatic leaders, especially in turbulent times, alleviate existential dread and instill a sense of pride, strength, and confidence that our group will last forever, and we with it. Numerous studies have demonstrated that when people are reminded of death, they become more committed to their cultural value systems. Researchers hypothesize that we tend to protect our cultural foundations because they provide us with symbolic immortality, helping us cope with our fear of death. Reminders of mortality make Christmas more fervent in persuading atheists to accept Jesus, and proponents of evolution more determined to convincing creationists to accept Darwin's theories. The act of converting others to our own beliefs reassures us. If I know that you have accepted my beliefs, I feel more confident and therefore less worried about my own mortality. If you ask any soldier what they are fighting for, it is unlikely they will mention benefits and increased territory or gaining access to the sea. People fight to expel those they consider infidels from sacred lands or to halt the perceived malignant spread of certain ideologies. Ultimately, they are fighting for their value systems, which they need to protect their perceived path to immortality. Director Woody Allen once said, "I don't want to achieve immortality through my work. I want to achieve immortality through not dying. I don't want to live on in the hearts of my countrymen. I want to live in my apartment." Humanity is delving deeper into the causes of aging and death, contributing to the extension of human lifespans. For example, recent advances in understanding the biological processes leading to death have in some cases made it possible to resuscitate people after extended periods following clinical death. Psychologists around the world have begun conducting research on the topic of immortality. Preliminary results suggest that as interest in literal immortality, such as through religious beliefs, increases, support for indefinite life extension decreases. Conversely, those who believe in the possibility of infinite life extension lose interest in the traditional literal immortality offered by religions. I have great respect for any willingly chosen path to immortality. Immortality has occupied and will continue to captivate our imaginations indefinitely. In pursuit of immortality, the most important thing is to remember to experience and cherish the life we currently have. Thank you very much for watching. If you enjoyed the video, give it a like and subscribe to the channel. Your support helps us move forward.